Hello. Hello everyone, my name is Anjali Priya. Today our project is about cold start delay analysis in serverless computing. In serverless computing there is a problem that will occur like cold start delay, which is about how the function is mostly occurring in the isolated areas. So we need to resolve this issue using our project solution. Actually there is a website like cloud. We'll go to the cloud website, which is AWS. In here we have been created some of the functions regarding lambda, because serverless computing mainly works in the lambda function itself. So these functions will work as a predictor like ML. We have been created ML model which will predict the cold start delay. I mean, how much of the delay it is occurring, how much of the isolation time, isolation duration it is occurring, and these type of data is created in these functions. Like this is the cold start ML predictor we have been created, which is an ML model. This cold start delay analysis on cold start Python 314, Python 310. These are the functions that will help us to check the different scenarios regarding how cold start is arising. And Python 314 and Python 310 is the versions of the Python where we can check how much of the cold start isolation duration is occurring, and we'll compare this data. And also with the help of cold start delay analysis we have been check different types of memory allocations that will give to the different types of functions in the lambda, so that it will help us to check how memory is varying between these functions. For example, let me check this cold start delay analysis function. Give me a few seconds, it will load, and after buffering we can go through this code and check what actually the code will work. Here is the website where we can get a code. This deploy function is used to deploy this code to the server and also to the database. This with the help of this test function we'll run this program. In this program we can see this import time and something like start time, time dot time function. These all will work as checking the duration between the execution time of this code and the isolation time to actually get the output. We'll let me check how it will test. After getting that time we can see there is some init duration in the output which actually says the cold start occurs. First of all, let me explain about what is the cold start. Cold start is nothing but how much of for example, let me have different types of functions in lambda, as I already showed to you. There are different types of execution times that will get to the functions in the lambda. If it is having the time duration between execution time and of actually implementation of the code, that is nothing but the init duration, how much of the function is isolatedly occurring. That is the main difference between the cold start and the warm start functions. So if the function output is having some init duration, which is nothing but initialization duration, it is considered as a cold start. And by this function we are checking, by this code we will check the init duration. If it is occur, we will consider it as a cold start. Let me go to the ML model, which is have been created a cold start ML predictor, which is a function which will go through under ML model that we created. The main motto of this function is to predict the cold start before it is occurring, nothing but predicting the data. Here we will take ideal time, execution time into this function, and we will check the, we will compare with the help of the console logs. Let me go to the console logs. Before, console logs are the logs that we use for recording different types of the output data after executing the lambda functions. There itself we can have different types of log data. Logs are nothing but the record, so that we can have from the execution data, from the console logs we can have ideal time and execution time. So after collecting these type of data we can be able to keep in the ML predictor, which will help us to predict the model. That is the main difference between lambda function and also the console logs. and also we automated the functions which will be able to keep the functions not ideal and make it as a warm start. And warm start is nothing but which is not get able to get the function to go ideal and make it as a warm start. So the actual implementation of this can be able to get through the Amazon Event Bridge. Amazon Event Bridge is the feature in AWS which will help us to automate or do the functions in a scheduled manner. Here we will prepare this Amazon Event Bridge under schedule rules. The name of the schedule rule that have been created is keep lambda warm rule, which will make us to do the functions that we have been created in lambda to make automated for the every 5 minutes, so that it doesn't go ideal to for too long time, so it will keep warm as well. That is the main importance of this Amazon Event Bridge. I think these are the some of the things that have been created in this. And also we have been done a major differentiating between the server computing and serverless computing. With the help of lambda we have been check different scenarios about serverless computing, and with the help of EC2 we have been created and compare the different results of server computing, like different models, ML models created in lambda as well as EC2. For example, let me go through the PPT and give a deep explanation of this particular slide. And these are the different test cases that have been done, like first invocation after ideal period, consecution invocation, Python runtime version change, memory allocation, event bridge automation, ML model. I think I have been shown you all of these test cases, and this is the main architecture of a project, where it able to differentiate the differences between cold start and the warm start. And actually I think I shown this output as well. And these are the different scenarios that will compare server and serverless based ML model, which can be done through lambda and EC2. And this is the flowchart that will compare the results of our project. I think I'll hold for few seconds and go through it. Yeah, let me go to the next slide. And this is the ML prediction model, how it is working. Actually we have been created the data, I mean we have been collected the data, we do some preparation on that, and next we'll I already shown this slide as well. Okay, this is the process flow for the ML model. Like first we collected the CloudWatch logs on log parsing, feature extraction, dataset preparation, logistic regression model we have been used for our ML prediction, and next the cold start prediction have been occurred. And the future scope and all conclusion, I think it is not needed for this slide. Okay, that's all about my project, and thank you for this. Thank you.